Hello dear student, today we will see number system conversion. So first we will see what kind of number we are having in the computerized system. In computerized system we see total 4 types of numbers are there like decimal, binary, octal and hexadecimal. So in the case of decimal, there is a base 10. So what is the meaning of base 10? Because we have total 10 symbol for representing decimal number. In mathematics, we use decimal number mostly. So we use the number from 0 to 9. So it is written like that. This is the example. In bracket we write 10. It means that whenever in computerized format in the computer subject you write the decimal number in bracket, after bracket we use the base 10. Why we use the base 10? Because we have total 10 symbol. Next is binary, there is a base 2 because we have only two symbols 0 and 1 and your computer understand only binary language. So here you see this is the example. Next one is a octal. There is a base 8 because we have total 8 symbol from 0 to 7. It is represented like this and the base is 8. Hexadecimal we have total 16 symbols, so base is 16. So we have the number 0 to 9. So 0 to 9 means total 10 symbol. Then A will represent number 10. B will represent number 11. So F will represent number 15 because we started with 0. So we have total 15 symbol there. Okay. So here in place of 10 we write the alphabets A. Then we write B and B will represent which number? B will represent 11. So in this way we use up to F. It is represented like this. 3dB. It is a hexadecimal number. Now we will see the conversion that is important to us, decimal to binary conversion. So this is the decimal number 43. When we convert into binary, we have to divide with the binary base. So binary number base is 2. So we have to divide 43 by 2. So we get the quotient 21. Okay, so you know, as you are a mathematics student, you know how to do the division. So it is a quotient and the remainder you have to note it down in the right hand side 1. Again you have to divide 21 by 2. So quotient will be 10. You have to note it down. Remainder will be 1. So you can again divide 10 by 2. 2 5s are 10. So remainder will be 0. Again 2 into 2 is 4. So remainder will be 1. Again here quotient is 1. So remainder will be 0. Then you in the last step you have to keep in mind 1 cannot be divided by 2. So here you write 0 and 1 will be shifted here. And then you have to count the digit from bottom side. So your binary number will be here 1. Next number will be what? 0. And next number is 1. You have to do it from bottom side. And here after 1 there is a 0. And again next number is 1. And last number is here 1. So that is what your binary number. And you can cross check also whether your answer is correct or wrong. How you will cross check? Because that from right hand side this number it represent 1, then you have to just double that number, so it will be 2. Again you have to double that number, it is 4. Again you have to double, it is 8. When you double this it is 16. When you double this it will be 32. So you have to do the addition of those number. There we have 1. So here 1 is there, here also 1, here 1, total 4 1. So here you do the addition. So here 1 is represented by 32. So you write 32 plus 0 represents 16. So you should not count because here it is 0. 1 represent 8. You should not count 4 because there is a 0. Then here 2, here 1. So 2 plus 1, 3. You can directly write. So here their addition will come 32 plus here 11. So it is what? 43. And finally that was your number. So it means your answer is correct. So in this way you can cross check also. Next we will see decimal to octal conversion. So this is your decimal number. For converting into octal, now you have to divide the octal base. Octal base is 8. So 8 fours are 32. So here 4 and the remainder will be 1. So now this is the smaller number. So you write 0. 4 is as it is. So 41 is your octal number. Next is hexadecimal. So you have to divide with the base of hexadecimal, that is 16. Quotient will be 26. Again you divide, quotient will be 1. And here this is the smaller number, write 0. 1 will be shifted here. So here these are the remainder. So 1A7, you have to count it from bottom side. So here 1A7 is your hexadecimal number. Next one is binary to decimal conversion. Now we will do it in opposite order. Binary to decimal conversion. So this is the binary number. So you write as it is. And here the important thing is that you have to do multiplication 1 into. Why we have written 2 raised to 4? That first digit from right hand side, it is 2 to the power of 0. Then here you do 2 to the power of 1, 2 to the power of 2, 2 power 3, 2 to the power of 4. So that's why here it is 2 raised to 4. Here then 1 you have to subtract, 2 raised to 3, 2 raised to 2, 2 raised to 1, 2 raised to 0. So here 2 power is 4. Okay. And here 1 is there, so you do multiplication with that, plus in the next step 0 is there, so you do multiplication with 0. Here 1 is there, you do multiplication with 1. So in this way you have to do. The main thing is the power, and here you have to use 2. Why we use 2? Because we are converting from binary to decimal and binary base is 2, so that's why we use 2 here. Then their calculation is 2 raised to 4 means you have to multiply 2 4 times, means 2 will be multiplied with itself, 2 is multiplied with itself total 4 times, so it will be 16. Then plus 0 with any number is 0. Here 2 raised to 2 means 2 into 2, so that is 4 into 1 is here 4. Next one is 0, so it will be ultimately 0. Then 2 raised to 0, that is always 1, so 1 into 1 is 1. Okay, so being a mathematics student, I think you will understand this easily. So last answer will be 21 basis 10. Next one is octal to decimal. So it is the same procedure, but here you have to do with the 8 power 4, then 8 power 3. Now you understood why we have written 0, then 1 2 3 4. So here it is 8 in place of 2, because we are converting from octal to decimal. And finally you do their addition with the final number. Next one is hexadecimal to decimal conversion. So here you have, in place of 8, now you have to use 16. Remaining procedure will be same. You have to do multiplication, then addition, and then this is your final answer. And now here you understood all the kinds of conversion. And now here we will go in the ID, and there we will see how you can get the various kinds of number. So here I open my ID, then here suppose I write binary, bin you have to write. So here I want to do binary of 12. So you see we got the answer. 0b represent it's a binary number. Then here 1100 it's a actual binary number. So here 0 means you can say 1, then this is 2, this is 4, and this is 8. 8 plus 4 is 12. So you know we do addition, so our answer is correct. And you can also convert back this binary to which number? Decimal. So what you will do, you write as it is 0b, and next is 1100. So you are getting the same answer, that is the decimal number. So in this way you can easily do in Python. Now in place of binary we want the octal. So I want the octal of simple number I am taking, so that you can understand easily. So this is what octal number we got it from this decimal number. So 14 is here octal number. Now as it is I am writing here 0O, and octal number is 14, so we get back the 12. So we got it here decimal number. Now next is hexadecimal. So I want the hexadecimal of 12, so it is C. Okay, C symbol represent the 12 number. Now when you convert back into the decimal, you write as it is 0x and C. So you are getting the 12. So in this way you can easily do the conversion in the Python. It is not hectic, it is very simple. So here these are the command that you have to practice. After the presentation you can easily understand. So thanks for watching this tutorial. Thank you.